last video, we discussed how to detect different objects using inductive proximity sensors. Detect different objects using capacitive proximity sensors. In continuation of that, in this video, we are going to discuss how to detect different objects using photoelectric proximity sensors. Let us discuss on photoelectric proximity sensors. Photoelectric proximity sensors, also known as photoelectric sensors or photo eyes, are devices used to detect the presence, absence, or distance of objects by using light. They are widely used in industrial automation, manufacturing, packaging, and various other applications due to their versatility and reliability. Photoelectric proximity sensors use light to detect the presence or absence of objects within their sensing range. They consist of an emitter, which emits light, and a receiver, which detects the light. When an object interrupts the light beam between the emitter and receiver, it triggers the sensor's output. In this mode, the emitter and receiver are placed opposite each other with a gap between them. When an object passes through this gap, it interrupts the light beam, causing a change in the receiver's output signal. Task 1. Detect different objects using photoelectric proximity sensors. Step 1. Determine the power requirements of your sensor. Most photoelectric sensors operate on low voltage DC power, commonly 12 volt or 24 volt DC. Check the datasheet of your sensor for the specific voltage and current requirements. Step 2. Connect the power supply to the sensor. Typically, this involves connecting the positive terminal of the power supply to the positive terminal of the sensor and the negative terminal of the power supply to the negative terminal of the sensor. Step 3. Connect the load like a lamp or buzzer for indication when an object is detected as per the connection given in the datasheet. Photoelectric sensors usually have an output signal that changes state when an object is detected. This output can either NPN, sinking, or PNP, sourcing, depending on the sensor type. Connect the output terminals of the sensor to the input of the device you want to control or monitor based on the detection. Step 4. Position the emitter and receiver of the sensor so that the light beam emitted by the emitter is aimed at the receiver. Ensure that the sensing area covers the region where you expect objects to be detected. Step 5. Power on the sensor and verify that it's functioning correctly. You can do this by observing the output signal of the sensor. When no object is blocking the light beam, the output should be in one state, either high or low, depending on the sensor type. And when an object interrupts the beam, the output should switch to the opposite state. Depending on your application, you might need to adjust the sensitivity or other settings on the sensor to optimize its performance for your specific requirements. Recap. In this video, we have discussed how to detect different objects using photoelectric proximity sensors.